Okay, let's get started on the conservation of energy. Thing to remember with these questions is that E total stays the same everywhere in the question. So that's step one for everything. Find out what the E total is. So first question is 300 kilogram snowmobiles traveling at 16 meters per second. So it's 300. And it's going to go over a cliff, a fluffy snowbank. It's 2.5 meters in the air. So to get E total, that would be right at the beginning. I have the velocity and have the height. So it's just EG plus EK. EG would be MGH. And EK would be MV squared, which is 300. Maybe we'll just do it straight up. 16 squared all over 2. And we'll get how much energy is available for this particular machine. So 7,350 joules of potential energy. 16 squared divided by 2 times 300. And we got 38,400 joules of kinetic energy. Add those two together. My total supply of energy is 45,750 joules. And that will be the same everywhere in that question. So let's see question A. It says, what's the total mechanical energy? So they're just looking for E total. We did that. Question B says, how fast will it be when it lands? Down here in the bottom. So at the bottom, height equals 0. So this was the answer for A. Let's get started on B. E total equals kinetic energy plus the gravitational energy. But if you're on the ground, this guy's just going to 0, which means all of the energy, which we know, is going into kinetic energy. Kinetic energy is mass times velocity squared divided by 2. If you look at the beginning, I multiply by 300, multiply by 300, and now I'm going to turn around and divide by 300, which means the mass pretty much always just cancels out. So if we rearrange this, solve for V, that number's on my screen, so just times it by 2, divided by 300, and then square root that, 17.5 when it hits the ground. I guess take a look at number 2 then. Number 2 says, let's cover it up here. Several children are pretending that they're playing at the jungle. They're going to swing on a rope then. Okay, so we got level ground, we got a rope. We got this kid that weighs 40 kilograms. And she's on the ground right now. And she's going to grab onto this rope. And they're going to swing up here somewhere, and they're going to get up here. Probably haven't read ahead yet, but and they're probably going to come to a stop. Maximum height, good. That would be different with, and how fast would, oh, they're just changing the mass, but we just said the mass cancels out, so that's not going to be an issue. But let's find out how high you get here. Okay, so step 1 is always find E total. And what I need to know is velocity for that one and height for that one. And we know that at the beginning, because I have the velocity. It was 8 meters per second. I didn't write it down. And the height is 0, which is a valid height, which just means this guy goes away. So my E total is totally kinetic energy. So 40, 8 squared over 2 equals, let's see, 8 squared times 40 divided by 2. Is 1,280 joules of energy. That's the total energy everywhere, halfway up the swing, all the way up the swing. It's always the same. So let's find out the maximum height. E total equals EK plus EG. Okay, we know E total, that's locked. The velocity will drop to 0 at the highest possible spot, so that guy's just going to go away. So we're going to go 1280 equals MGH. The mass is 40 for this kid. G is 9.8. I'm just going to find H. That number's on my screen. So I can divide by 40, divide by 9.8. The height would be 3.3 meters. And B, it's just a word question. It says, how fast would a 40 kilogram or how fast would a 30 kilogram kid go? And you'll notice that whatever I multiply here, multiply by 40 to get these values, and at the end when I solve for my unknown, I'll be dividing by the mass, so it's always going to cancel out. So that's just 8 meters per second. Okay, let's do the next question. Question 3. An amusement park slide. Participants have set in a cloth to sit on. The slide 6 meters tall. Okay, so here's the slide, 6 meters tall. And determine the speed they get to the bottom. They start from rest. So at the top, we got our kid, 30 kilogram child. V equals 0. So I have V and have H. I have the two values, so I can get E total right away. I guess I got to get E kinetic, which would be mass, times velocity, so being silly, because it's sitting still at the top. G is just mgh, so it'll be 39.8 times 6. So 30 times 9.8 times 6 is 1,764 joules. And they said, what's the speed when they get to the bottom? Assume that friction's ignored. So they're going to get all the way down to the bottom at this particular spot here. That's for question A. E total equals EK plus EG. This time, I'm on the ground, so H is 0. So right away we can cancel that guy out. E total stays the same for the whole question. So 1764 will equal the mass of the child, which is 30, V squared all over 2. That number's on the screen, so just times 2, divide by 30, and then square root to get rid of that. We get 10.8, or 11 meters per second. Now B says, repeat your calculations, but this time assume that 80% of the energy is lost. It's a friction. Okay, so it has to overcome friction. So this here, for if we do question B, when I bring this down here, 80% is just going to disappear, which is going to leave me with 20%. So we go 1764 times 20%. E total, when we get to the bottom, is only 352.8 joules. Because 80% of the energy just disappeared. So if I solve for the velocity at the bottom, including friction, same steps we did here. 352.8 equals 30 V squared over 2, and now we have to solve for V. That number's already on the screen, times 2, divided by 30, square root. It's 4.8. A little more realistic. We don't want to get the kids hurt when they come flying out the bottom.